Hello, welcome to questions 24 through 29 from Chapter 6. Question 24. A study was done for a vitamin supplement that claims to shorten the length of the common cold. The data the scientists collected from 10 patients in an early study are shown in the table below. So you have your independent variable, the number of months taking the supplement, and the dependent variable, the number of days the cold lasted. So we want to describe the association. So let's just start there. We want to describe the association. So remember what we want to talk about. We want to talk about the direction, the strength, what form, and then do you feel like there's any outliers? So as you go to describe the association, make sure you create your scatter plot. I'm not going to do that on this video specifically, but go ahead and create your scatter plot and identify the association from that. You should come out that the direction is negative. It is a moderate strength. The form appears to be linear, and that there are no apparent outliers. Part B, model the data with a line of best fit. According to your model, how many days do you expect a cold to last for a patient taking the supplement for 1.5 months. So once again, all this stuff is going to be different because it's your model. The data is the same, but your line of best fit could be different. So based on, I'm going to just show you based on the line of best fit that was created, and on that one, approximate what that supplement, how long it would last. So for part B, the equation would be y is equal to negative 1.6x plus 5. So that's my line of best fit modeling the data. And based off of that, if I wanted to figure out how many days do we expect the cold to last for a patient taking the supplement 1.5 months, we will plug that in for x. So we'll get negative 1.6 times 1.5 plus 5. And that comes out to be 2.6 days. So that's what the prediction is for B based on my equation and my line of best fit. Yours would obviously be different, but should be close to that value. On part C, calculate the residual for 1.5 months. Interpret the residual in the context of the problem. So at 1.5, the actual data is 3.3 number of days the cold lasted. So the residual is equal to the actual, which is 3.3, minus the predicted, and then that will give you approximately 0.7 days. So once again, it's the actual minus the predicted, which is down here, and that will give you approximately 0.7 days. Interpret the residual in the context of the problem. So what this means is the cold actually lasted 0.7 days longer than was predicted by the linear model. And so there on the bottom, the cold actually lasted 0.7 days longer than was predicted by the linear model. And then the last one we're going to look at is part D. And interpret the Y-intercept in context. So the Y-intercept for my model that I have for my equation is 0.5. And so I'm going to go up to the table and show you this. So this would be 0 and this would be 5, which means if they didn't take any supplements at all, the cold would last approximately 5 days. So basically what it's saying is the average cold is about 5 days long. And so then that finishes up the problem dealing with the scatter plot, line of best fit, and interpreting some of the information and data. Question 25. Write an explicit equation for the sequence based on the graph below. We did one of these the other day, and it was an arithmetic sequence. It was linear. Let's take a look at this one. So we want to label these points. The first one is 1 comma, and when you look at the y-axis, 1, 2, 3, 4, 5 to get to 20. So it looks like they're going up by 4s. So 4, 8, 12 right there. So 1 comma 12. And then the next one is 2 comma 4 before 36, before 40 be 36. And then this one would be 3 comma, we got 100, 4, 8. So 108. Okay, so when we're looking at this, we have to decide with our sequence, term 1 is 12, term 2 is 36, and term 3 is 108. So if we look at it, it's definitely not linear. You see it's increasing a lot quicker than linear. So if we multiply this by 3, that would give us 36. And if we multiply 36 by 3, we get 108. So it does look like it is a geometric sequence. We're missing the term 0, which we need. So we have to go back to term 0. If we're multiplying by 3, then we can divide by 3 to work backwards. 12 divided by 3 is 4. So we now have term 0 is 4, and we are multiplying by 3. So we know our multiplier. So that gives us enough information to write our sequence. T of n is equal to the initial one, which is at term 0, 4, times our multiplier, which is 3, and that's going to keep happening, so we raise it to the nth power. And there's your equation. You could also use the alternative notation, a sub n is equal to 4 times 3 raised to the n. So either one of those would be fine. But we are writing, once again, the explicit equation, not the recursive. Question 26. A line with a slope of negative 2/3 passes through the point negative 12, 16. What is the equation of the line, and what is the x-intercept? So given a slope and a point, we've written equations a lot at this point, and with given this information. So should feel pretty comfortable with this. We're going to use the equation y equals mx plus b. We're going to plug in the information that we know, and then we will solve for b. So 16 is equal to positive 8 plus b, subtract the 8 to both sides, and 8 is equal to b. So we can write our equation. Y is equal to negative 2/3 x plus 8. On part B, we want to find the x-intercept. Now we know what the y-intercept is. It's 0, 8. But what we don't know is the x-intercept. We can't find that just by looking at the equation. We do know the x-intercept, the y value is 0, so we can take the equation that we found, plug in 0 for y, and now solve for x. So we'll subtract the 8 to the other side. I'll do this part in 2 steps just to make sure. We're going to multiply both sides by 3. So that's negative 24 equals negative 2x. Divide by negative 2, and x is equal to 12. And we don't want to leave our answer just as x is equal to 12. We want to write it as an ordered pair. It's an intercept where the graph crosses the x-axis. So 12, 0 would be the x-intercept. 27. For each generic rectangle, fill in the missing parts. Write an equation showing the area as a sum equal to the area as a product. So you're looking at part A here. We have x and y as your first block. We don't know the second. And then the third one is y squared. But then we also have this length is x, and this length is 3. So if we know this length is x and we know the area is xy, what's the only way that you can multiply something times x to get xy? That would be if that was y. So y times x is xy. Now if we know that, now we have 3 times this length, which is the same as this length. So 3 times y is going to be 3y. And then I think the only other thing we're missing is this side length down here. So y times what gives you y squared? And that would be y times y. So if we're writing it as the area of a sum equal to the area of the product, the sum is just taking each of those blocks and adding them up. xy plus 3y plus y squared. And none of those are like terms. They don't all have the same variable raised to the same power. And it's equal to y times, so the y is this side, times all of this side. So that would be y times x, y, plus 3y, plus, or hold on, I think I messed up. Yeah, go back. So this side is x, 3, and y. So sorry about that. It'd be x plus 3 plus y. And so that's the sum, and then this is the product. All right, let's take a look at B. So on B, we have 3, and we don't know this side, and we also don't know this side. So to get 8x and x squared, how are we going to find what that side length is? Well, what you can look at is, what do these two things have in common? All right, they both have an x. So that means this side length would be x. All right. And so to get the 8x, what times x gives you 8x, or 8x divided by x is 8. So 8 times x is 8x. And then the same thing with the x squared. I need to know what this side length right here is. So what times what gives you x squared, or x times what gives you x squared, and that's x. So just kind of trying to puzzle our way through this, and now that we have these two links, we have 8 times 3 is 24, so we can fill out that area, and then 3 times x is 3x here. So once again, the sum, we're just going to add things up in the middle, so that's x squared. You do have 8x plus 3x, so I'm going to add those up to get 11x, and then you're plus 24. And then the product is you have one side length that's x plus 3, and it's times the other side length, which is x plus 8. So once again, this side represents the product, which is basically the length times width, and then this is the sum, which represents the area simplified. Question 28. Make a complete graph of f of x equals the square root of x plus 2, label its x and y intercepts, and describe its domain and range. So if we want to graph this, we graphed these earlier on, but if we want to graph this to get an idea of what we're looking at, we're just going to use a t-chart, input output table, and plug some values in. Now if you remember from the beginning of the year, we couldn't just plug in any values because some of those didn't work. And so just to kind of start this off, I'm just going to start with some numbers here, and we'll see what happens as we go along. So if I plug in -3, that would be the square root of -3 plus 2, which is the square root of -1. That is an error. There's a domain error there. If I plug in -2, -2 plus 2 is the square root of 0, but the square root of 0 does exist, so -2 does work. Anything underneath the square root that is greater than or equal to 0 will work, and so -2 makes that 0. And now as we go along here, we're going to notice all the numbers underneath the square root are positive. So we'll just keep plugging these numbers in and seeing what happens. Now this square root of 2 is not a nice one, so I could approximate it and graph that. I'm going to keep going until hopefully I find another nice one. So 1 plus 2, well the square root of 3, that's not nice. When do I get my next nice square root? Well that's going to happen at 4. So 2 plus 2 is the square root of 4, and that's equal to 2. And I can continue on again all the way through until I get to my next square root. What's my next square root that's nice? We got 0, 1, 4, and then the next one would be 9. The square root of 9 is 3. What number would I have to plug in to add to 2 to get 9? And that would be 7. Okay, so I'm going to go back to my table here, and I'm going to eliminate some of these numbers that I don't necessarily need. -1 worked. 2 was going to be a decimal. 3 was going to be, if I plugged in 0, that was going to be a decimal. If I plugged in 1, a decimal. But when I plugged in 2, I got an output of 2. And when I plugged in 7, I got an output of 3. So those are the ones I'm going to graph. So -3 I can't graph. -2 is at 0, so I can get that one. -1 is at 1. 2 is at 2. And then 7 is at 3. And if you guys remember, the square root function is half of our u-shaped quadratic function. So label its x and y intercepts. Well, the x-intercept is at -2, 0. The y-intercept, well, what is the y-intercept? It doesn't look like it intersects nicely. The y-intercept is when x is 0. So if I plug in 0, which we did, actually, I'll just go over here. We did plug in 0 right here. And we got the square root of 2. So the y-intercept, when you plugged in 0, you got the square root of 2. Definitely not a nice number in terms of an integer, but it'll work. And then describe its domain and range. So the domain is your x values, so that's this. Your domain is all values greater than or equal to -2. You can't go left of -2 because then you'll get an error. So your domain is your x values that are greater than or equal to -2. And your range values are your y values, and that goes as low as 0, but then it gets larger as you plug in larger numbers. So your range value is y values that are greater than or equal to 0. So we have the graph, we have the intercepts, and we have the domain and range. 29. This problem is the checkpoint for rewriting equations with more than one variable. It will be referred to as checkpoint 6a. Solve each equation for the indicated variable. So on part A, we're solving for the y value. So we will add 3x to both sides. That is 5y equals 3x minus 10. And then we will divide everything by 5. So y is equal to, you could leave it as 3x minus 10 all divided by 5. Or if you wanted to rewrite it as 3/5 x minus 2, that would also be okay. So either one of these would be acceptable. On part B, we're solving for x, and it is the equation in slope-intercept form. We will subtract the b first. And since it's being times x, we can divide by the slope. So x is equal to y minus b divided by n. And then the last one, c. We are solving for r squared. So we're not solving for r, but r squared. So since it's a equals pi r squared, we just need to divide by the pi value. Don't input what a pi approximately is, just leave it. And that will give us r squared is equal to a divided by pi. And just leave it just like that since we're solving just for r squared.